Okay, we're about to, in this video, we'll discuss Chapter 2, Section 5 of the textbook. It describes, very briefly, several process model: prototyping process model, evolutionary process model, spiral process model, unified process model, uh, personal software process model, team software process model, and agile process models. The reason that this is plural, that means there are actually more than one agile process. Probably you have heard of the term prototype. Uh, Prototype means something not necessarily the real product, but something that gives you the look and feel of the real product. And it's quite different from the real product. For example, consider if you are creating a software that, let's say, a cashier software, point of sale software that can scan some product at the supermarket and then do some calculation for you. So a real product can scan anything and do all the calculation for any products that you want. But what is a prototype would look like or work like? A prototype um, may not be able to uh, calculate um, the scanning of many products. Maybe it can, whatever you scan, it will only show the same product. And so it just try to give you the look and feel of how the product would look like without actually calculating everything correctly. So perhaps you can only scan several products, so other products may not be supported. Okay, so that um, so so that the creation of prototype can reduce the actual time that comparing to creating the real final product. Um, so that is to we're trying to validate the requirements, because a user may tell us something, but then after we do something to show to the user may figure out, oh, maybe what they told us earlier may not be their real requirements. Maybe now they think something else should be done. So that is to validate by collecting feedback from the customer. And also it helps us to help the developer to see how feasible it is to do certain things. Maybe it's not feasible. Maybe it's the idea maybe it's turned out too complicated. It cannot be made user friendly enough. So that are some feasibility that we can look at. Okay, either it is technically too difficult, or like to implement, or it may be uh, not usable for the target user because it's not easy to use or something like that. Okay, there are two kinds of prototypes. Prototypes that you throw away. So after doing it, creating a prototype, you will not build on top of it to create a real product. But there is another kind of another kind of products. We call it evolutionary products that you can refine and turn it gradually, step by step, into the final product. So let's see. So a throwaway prototypes can help us get feedback very quickly. And maybe we would be using a tool different kind of tool for throwaway prototype. But evolutionary prototype, we will probably use a programming tool that's very similar to the real development. So that one difference between the throwaway prototype and evolutionary prototype is that perhaps they may be using different types of tools. For the throwaway prototype, maybe it's just some screen drawing tool that we use to create a prototype, but the evolutionary prototype probably would use some programmer's tool to do that. So the benefit of using throwaway prototype is, well, since it doesn't need to become the real product, so it does not require support of the programming tools. So any screen drawing tool, screen throw tools can be used for the throwaway prototype. But so that allow some UI designer to do that perhaps more quickly. So that was require less time to create a prototype, but then it is somewhat wasteful because you cannot reuse the prototype to be part of the final product. So throwaway prototypes usually take less time to create, but the time we waste or we spend would not would not help us a whole lot in building the final actual product. But evolutionary prototype may take a little bit longer to create, but the time we spend can be saved when we create the final product. So this is a judgment call which kind of prototyping you can use. So it's not always one being better than the other. Okay? But when do you use prototype? Well, if we are creating something very innovative, very new, and we don't know, we don't think we can predict user responses, so we can use a prototype to see how user like or dislike it. Okay, but if the product is going to be very familiar with some existing product, for example, a run-of-the-mill point of sale system. Point of sales means like cashier product. The word run-of-the-mill means very average, very standard, very common. Okay, so if we're creating a very common cashier system, then there's probably no need to create a prototype because we sort of can predict how user will respond to the workflow, the design, and so on. So prototype has its benefits, which is to when we are creating something innovative, but it's not always useful. Okay. Spiral process model is when it was invented, maybe 3-4 decades ago, it's quite innovative. It tries to address the drawback of the waterfall process. Okay? Because waterfall process, one of the drawback of waterfall process is that users have to wait months or even years before they can see something working. So we cannot collect feedback. So the spiral model try to incorporate prototyping into its process. So it starts from this top left quadrant, it goes like this. So each times around, we identify some risk and we create a prototype to address the risk. And then start to formulate the concept, and then here get through the requirements and do more planning. And each time around, going around the spiral, you add more information. For example, this time around, from the concept of operations, you start to look at requirements, and then now you have the development plan, and you continue with more prototyping. Now you get into the design. You actually verify and validate your design, and then you start to have test integration plan and test plan. You continue until you have a more or less operational prototype, and from there you go through the phases of the waterfall model of uh, detailed design, coding, unit testing, integration, acceptance testing, and deployment. Okay, so it is the idea of the spiral process model is to use several times prototypes to increase our understanding until we have good enough understanding. Then we, through a number of successive prototypes, then we go through the waterfall model to create the actual product. So it tries to combine the benefits of prototyping and the waterfall. So you can think of the spiral process model very much as an evolutionary prototyping. Um, uh, Let me emphasize the terminology. In the textbook, it talks about prototyping that can be throwaway and evolutionary. Then the author go on to use the term evolutionary process model. But not everyone in software engineering use this term. So lots of people consider evolutionary process as a a case of prototyping, that a prototype can be throwaway and evolutionary. So many people do not refer to a separate process called evolutionary process. It's in software engineering, we sometimes have to deal with this terminology thing. It's quite complex because some people use certain terms and some people don't use certain terms. Some people use two different terms to refer to the same thing, so that can be sometimes confusing. But that is the way of life in software engineering. Now let's turn to another quite well-known process called rational unified process, or sometimes people call unified process. There's a minor difference between the two, but we won't get into that. We can, for our purpose, we consider them the same or similar. In a project, a rough project, we divide the time into iterations. So iterations may be 1 week all the way up to 2 months. And it divides a project into 4 phases: inception phase, elaboration phase, construction phase, and transition phase. And requirements, analysis, design, implementation, it means coding and testing. These names, you may recall it from the waterfall model. Okay, in the waterfall model, you finish everything here before you start here. But in the rational unified process, you can see that in the horizontal refer to the time. So in an early iteration, we spend more time doing requirements, and then gradually we do a little bit of analysis and design, and the more we go on, the less we do requirements, but the more we do coding and perhaps testing. So rational unified process is different from the waterfall in that requirements you can do it for maybe the first half of the project. Okay? And so not you don't have to finish all the requirements before you go on to do the design. Okay? It's not necessary in rational unified process. You just do more of those earlier workflow in the earlier part of the project, and then more coding at the later part of the project. Somehow the textbook only shows the first 5 workflows, but in later, more newer definition of RUP, there are a total of 9 disciplines or workflows. So there are 6 technical or engineering disciplines, and then 3 supporting disciplines. So the supporting disciplines is more about management, like people, how people manage things, and 6 is more about technical things, the business modeling, requirements, analysis and design, implementation, test, and deployment are more technical. This is another more colorful drawing that shows the 6 engineering. You can see how more modeling was done in the beginning phase. There are 4 phases, okay, and then later on more coding effort, testing effort, and deployment is for the later. And oh, okay, so here we have a description of the 4 phases from the top that you see. Inceptions usually has not too many iterations. It produces some use case model, architecture, project plan. We'll see examples of those later. And elaborations really focus on the design. So you do more design. Okay? And the constructions will focus more on coding. And the transition focus more on deployment, including user training and maybe debugging. So they, for example, the design activity, by no means you have to finish at inceptions. You can still do a little bit of design in construction. So this is, you can think of it as an improved way of the waterfall model. Personal software process model is covered in the textbook, but I personally do not know this being used popularly. And also this is PSP actually is a framework more for one individual rather than a team working together. So we won't uh, focus too much on this one. Okay, but just to let you know that this is a framework for one individual to record how he or she does things. For example, his productivity or the bugs that he has created in his coding. Use that sort of data to see if to see how he or she can improve in his work. So PSP is more for personal improvement rather than a team improvement. Okay, so that's why it's called personal software process model. Okay, so we won't. Well, if we have collect data, then we can predict how productive a person is, and and also predict the quality, the work quality, and it will help planning and scheduling. Um, Team software process is another approach that has not been too popular either. Okay, there's a spelling mistake. This should be launch. That means some sort of planning to do at the beginning, and this so there's strategy, planning, requirements, design, uh, implementation, testing, post-mortem. It means at the end you try to look at what you did right and what you did wrong to improve another cycle. So very much the TSP is has the idea of cycles, okay, or sometimes it's called iterations, or in some other things that we learn is called it may be called sprint, but we'll talk about that later. And now finally, in the next section we will talk more about agile process, like in the next one or two session. So agile process try to divide the time into fixed time box. Okay? So let's say that means in 2 weeks you want to go through the requirements analysis, design, coding, testing, and deployment, everything in 2 weeks. But of course, 2 weeks is not a long time, so you can only do that for one or two features of your product. So you cannot complete the entire product. And that features, we sometimes call it user stories or use case. So one or two or several small features for the team to work together, and the team would complete all these in 2 weeks' time. So that address a shortcoming of waterfall. Even you can see these activities happen in waterfall, but by focusing on one or two feature of the product, you complete that one feature and show it to the user, and even the user may be able to start using the product very soon, even within weeks. So that is a very brief look at several kinds of software processes, including so for our purpose, prototyping is a little bit more important, and spiral is important for the conceptual and unified process, and then finally agile process are the more important ones.